Hello team, today's challenge is offending element, where we're given an array and we need to find the element that is out of place. So all these arrays are sorted lowest to highest, and inside of each of them is a mistake. So in the first one, the 6, it really should be the last element, but they've made it the second element, index 1, right? And that's exactly what we have to return. We have to return the index, not the actual element. But the challenge here is as we go through, yes, I can see that 6 is greater than 2. So I can compare it against the next index, right? And same with this, I can see that 5 is greater than 4 and 2 is greater than 1. But here, 4 is greater than 1. But 1 is the mistake, right? And so that simple logic that we use for these three is not going to cut it for these last two, right? 55 is greater than 15. Instead, what we need to do is do a different comparison, right? We need to test not only the current index and the next index, but we also need to test the next index and the last index. And I'll show you what that looks like right now, okay? So right here, I'm going to set up a for loop, okay? It's going to be actually I want this to be index equals 0, and index is less than array.length, brilliant, and index plus plus, okay? And we're going to do stuff in here. The reason for the for loop is that we can return early, right? If we use something like a reduce, we would have to loop over every single element, even if we found the element that we want right at the start, right? We'd still have to complete that entire loop. With a for loop, we can exit early. We don't have to worry about that. So for loop is where we live today, okay? If we get past this loop, we won't today, but if we were to send something in here that is properly sorted and has 0 mistakes, then we aren't going to find an index, right? So we should return something. And in the case of a tool like find index, it would return -1. Now, why aren't we using find index in here? Well, because of what I said, right? If we get in here with this example, I'm going to hit, the first test is going to be exactly that. It's going to test to see if the current index is greater than the next index. But that doesn't actually tell us which of those two indexes is the mistake. It only tells us that we've hit a glitch, that we've hit something that we need to test further, okay? So if we run into this, we might actually return 1 when we meant to return 2, the indexes, not the numbers, right? Index 1, index 2. And so we need that extra test, which is why find index, the method, would not work here too, okay? So back to the code. Over here, we're going to jump right in and do that exact first test, okay? It's going to be array index, okay? And we're going to see if it is greater than array index plus 1, okay? If it is, great, we've found the glitch. We just don't know if it's array index that is causing the problem or array index plus 1, okay? That's what we need to test next. And we can do that as part of a ternary. So we can actually return straight from this because we know one of these is the problem, right? We just need to test which one. So the test for that is testing the number before and the number after. And if they are in a logical order, then the current index is our problem. If they are swapped, right? If the index plus 1 is less than the index -1, then we know that index plus 1 is the problem, okay? So right here, we test exactly that. We go array index plus 1, and we see if it is less than array index -1. If it is, then we return index plus 1, okay? Because that's the problem. If it is not, then we already have the problem. That is the current index, okay? So with that, it absolutely works. The question is, again, maybe it's not quite clear how it works, okay? So let's go and grab a comment and work through it, okay? Just like this, correcting my indenting. So this is problem 1, and I think this one was problem 4, okay? Problem 1, problem 4, excellent. We go through, and again, we iterate over the loop until we find the glitch. And the glitch is wherever we have the current index greater than the next index. So in the case of the first one, 6 is greater than 2. That is our glitch. We just don't know if 6 or 2 are the correct answer. So we do our next test. We test 2 against 1. We see if 2 is less than 1. And if it is, then we know that it is then 2 is the error. Okay. But in this case, 2 is not less than 1. It is greater than. So 6 is where it's at, which is why we return that index. Okay. And we return it right there. We don't have to do all the rest of this. So saves us a lot of performance as well. Okay. Second example, right? We have a similar thing where 4 is greater than 1, but we don't know if 4 or 1 are our problem. So we check it again, right? We go to the second test where we say, is 1 less than 2? Well, in this case, it absolutely is, right? So 1 is considered to be the problem, and we return index plus 1, right? In the first one, we return index because that was our problem. In the second one, we returned index plus 1 because we discovered that that was our problem. And that's based on the current index and a comparison of its nearest siblings. Okay. The current index here being, well, for both of these actually 1, right? And then we test 1 plus 1, that's 2. 1 minus 1, that's 0, right? And we figure it out. And then, of course, if we pass right through this, we've tested everything, it is properly sorted, so we return -1. Could we throw an error there? Yeah, right? Discussions. Things that you need to talk with your team about to see what the right answer is. That's it. That's the challenge for today. Again, not every solution, just hopefully one good solution, right? If something didn't make sense, or you hated it, or you liked it, or any of that stuff, let me know in the comments. If you found a different way that you want to share, also put that in the comments. Otherwise, this has been Offending Element, and I will see you tomorrow.